Hello, my name is Alan Tier. I work in the polyurethane department of Baydur, and I'm going to talk to you about Baydur and Bayflex. These are the Baydur trade names for integral skin polyurethane moldable systems. Baydur generally are the rigid systems and Bayflex the flexible or semi-flexible systems. What do we mean by integral skin? Well, here we have a partial cross-section through the wall of a moulding, and you can see a solid skin zone, which is usually 1 to 2 millimeters thick, and a cellular core. Some of the systems are in fact solid, so then there will of course be no cellular core. How are these systems processed, moulded? Well, we use the reaction injection moulding process by which the two liquid raw materials are mixed together in a mix head, and the resultant reaction mixture is dispensed into the mould cavity, either through a simple hole or through a more complex, sophisticated gate design, depending on the system. It's important to realise that with the lower density systems, the cavity is not completely filled by this reaction mixture, which subsequently reacts and expands to fill the cavity. This has some important implications on the design of the mould, which we can explain to you if you select this material. So we have a low viscosity reaction mixture, which results in excellent flow properties, and a low internal mould pressure compared to conventional injection moulding, which means that we can use economical aluminium moulds or sometimes even epoxy resin moulds for prototype work, and silicon rubber moulds, as you'll see later, for certain applications. Now, the key properties of the brand in general are versatility through adjusting individual product properties. This means we can adjust the chemistry of the raw materials to produce a wide range of physical properties in the end material. We have economic production of large parts, not simply because the moulds are cheaper than those used for injection moulding, but because a reaction injection moulding machine with the same capacity as a conventional injection machine would be a quarter of the price or so. We have excellent reproducibility of detailed surfaces because of the low viscosity of the reaction mixture, despite the low moulding pressure. And we can use Baydur and Bayflex with, or in combination with, other raw materials. Now here I perhaps should mention the disadvantage of most grades of Baydur and Bayflex, in that they're not light stable. Any light containing a content of UV will result in a darkening of brown coloration of the surface, although the physical properties of the material are insignificantly affected. This means that it is possible to make mouldings pigmented dark colours without really any apparent deterioration in the colour over the term of use of the product. But if pastel shades are required, then usually the mouldings require either painting or an in-mould coating or some other process to achieve the desired finish. Now the product range is shown here. For the grades with a number, after the number refers to the overall density of the material, we have to multiply it by 10. So for example, 20 times 10 is 200, which means 200 kilograms per cubic meter. And Baydur 110 is 1,100 kilograms per cubic meter, which is effectively fully dense material. Now I'll give you some examples of components and parts made in the various grades of Baydur and Bayflex. First we start with Baydur 20, the low density material, which is frequently used for coving and other decorative architectural components, as shown in this illustration. Baydur 40, this slightly higher density, can be used as a replacement for wood for structural components. These types of mouldings are frequently made in silicon rubber moulds, where an in-mould coating is used to get the base colour, and subsequent post-finishing is used to achieve the effective appearance of wood. Another example of an application for the Baydur 40 as a wood replacement is in this piano housing, where the curved sections are made from Baydur 40. Baydur has very good acoustic properties, so is ideal for this application. Here another example, a very large set of mouldings made in relatively small numbers, again which suits Baydur 60. And here we have an application which has been around for very many years. The cores of skis and snowboards are frequently made of Baydur. This is a classic example of a Baydur 60 moulding. This was first made in the 1960s and is, I understand, still being made. To achieve the high-class finish, these mouldings are painted subsequent to moulding. This is an interesting example in that it's made in relatively high numbers where thermoplastic material may have been competitive, but the designer and the manufacturer still chose Baydur 60 for this component. Now we move on to Baydur 110, which is a much more robust material, being fully solid and can be used in much more aggressive environments, as in this example. We have an example here of a foil being used in the mould to achieve the finish required. In this example, the foil is first of all placed in the mould and the mould closed, and the Baydur 110 is injected into the cavity to form the shell of the door. Then the lid, so to speak, of the mould is replaced to form a larger cavity behind the moulding, so that low density polyurethane foam can be injected to achieve the insulation that's required for this application. Another example of a Baydur 110 moulding here, this buggy trailer, which I'm sure you've all seen, which clips on the back of a pushchair. This refrigerator was designed around the turn of the century and was, I understand, quite popular in Italy and one or two other countries. I'm showing you this illustration just to indicate that it is possible to use multi-cavity tools with Baydur 110 and with the other solid Baydur and Bayflex types. It's more difficult, although it can be done, with the lower density grades. Yet another example, Baydur 110, a very large moulding made in relatively small numbers. And here we have Baydur CSP, which is a castable system which moulds at relatively low pressures. The barrel section of this chair is made in Baydur CSP, and then of course it's upholstered. One other property of polyurethane I haven't as yet mentioned is its very high abrasive resistance, which is a requirement for this pump housing and rotor, which pumps agricultural feed slurry. Baydur GS can be used as a cast iron replacement for street furniture, as in this example. And finally, an example of the use of Baydur GS from Italy. The keel and the rudder of this small boat are made in Baydur GS. And now we move on to Bayflex Integral, the key properties of which are that it has a thick abrasion-resistant skin, a flexible soft score, and it's got high tear resistance and flexibility even at low temperatures. Here we have an example, this chair where the cubes are made out of Bayflex Integral and the red colour is achieved by in-mould coating. And this playground ride, the saddle or the seat, is made from Bayflex Integral. And this example, the bumper or the dodgem car here, all the internal soft components, the seats, the steering wheel and the fascia, are all made from Bayflex Integral. In this instance, they are simply black pigmented and no further finishing is required. Now we move on to Bayflex Solid, key properties of which are it has a high impact strength even at low temperatures, economic production of large parts, and a high stiffness is possible by the use of fillers, as for example in this moulding, which is a snow scooter hood made of Bayflex 110 with the addition of 20% of glass fibre. And finally we have an example from the USA. This snowshoe is made of Bayflex Solid, which is moulded around an aluminium alloy insert. I hope that's been very useful for you, and of course if you have any questions about these materials and you want to contact me or my colleagues, then please use the various means on the website.